So a function is no repeat x values. Not a function is repeat x values, or we see repeats. Now, these first three examples here are ordered pairs. And when we look at ordered pairs, okay, ordered pairs are written as x, comma, y. So we're going to be looking at to see if that front number in the parentheses repeats. We don't want it to repeat, so that's why we're going to look. So what we're going to do is we're going to go through this first row here, and we're going to highlight all the x values. So this first one, we have -7. The second ordered pair, our x value is 3. The third ordered pair, our x value is 8. The fourth ordered pair, our x value is -6. And this last ordered pair, our x value is -2. Of the ones that I have highlighted, are there any repeats? No. So I'm going to write it is a function because there are no repeats. Okay? It is a function because there are no repeats. Let's look at the next example. So again, let's go through, highlight all the x values. So in this first ordered pair, it's the 9. In the second ordered pair, it's the 0. In the third ordered pair, it's 4. Then we have 5. Then we have 2. Then we have 0. And then we have 3. So, are there any repeats? What is repeated? 0. So for this one, it is not a function because there is a repeat of 0. Okay, it is not a function because there is a repeat of 0. So why don't y'all go through this last one here and tell me what you see? That's right. This one is a function because there are no repeats. We have 1, then there's 2, then there's 3, 4, 5, 6, 7, 8. So it is a function because there are no repeats. I feel like that's how you spell repeats. Not sure. Very good. Very good. So when we look at tables, okay, we look at the left side of the table. So like these guys at the bottom here, it says X at the top. So we look at those X value, that column, okay? Whereas these two tables say input and output. Input is technically your X value. So just know that you look at the left, okay? So looking at these X values for this particular table, is it a function or is it not a function? Tell me why. Why? Yep, it's a function, no repeats. I'm gonna shorten this down a little bit so we're not typing so much. So it's a function, no repeats. What about the table to the, what side of the screen is that? The right side. What about this right side? Tell me. Not a function. Why is it not a function? Absolutely, 2 4s. We have 2 4s here. Okay. So when I write out this, write this out, write out this, write this out. I don't know. What's the right word to say? Say not a function or not function. Repeat 4. What about our next table over here? The the, I don't know, or middle left. What about this guy? Why not? That's right. So this is not a function. Repeat zeros. What about this gray one over here? Why is it a function? Yep, no repeats. No repeats. Let's look at the next one. Tell me about this guy. Why? No repeats. All right, last one. Last one. Tell me about it. Oops. New voice. I want a new voice. What about this last one here? Absolutely correct. Okay. This one is not a function because it repeats 8. So not a function. Repeat 8. Very good. Very good. Okay. So now we're going to go through this next slide together. Okay. And then I'm going to have y'all do the orange graph on your own. Okay. So we're going to go through this one at a time, step by step. Don't freak out. So first things first, we're going to figure out where the graph is increasing. Now, how do we read a graph? Do we read it from left to right to left, bottom to top, or top to bottom? How should we read a graph? Left to right, 100%. So when I go from left to right, I'm looking to see where my graph is going up, like how my hand is doing right now. Okay? So when you look at that, we're going to highlight them. Okay? So we're going to break these up into sections. Let's do that. So we have the first section, second section, third section, fourth section, fifth, and sixth. Is everybody with me on breaking up those sections? Which section, give me one section that is increasing. So this first section here is increasing. And I'm going to highlight that. Okay. What's another section that is increasing? 1, 2, 3, 4, 5, or 6. 5 is increasing. Beautiful. So I'm going to highlight that entire section. Okay. Now we're just going to go through this increasing together. When we talk about increasing, we're looking at our x values of where it's increasing, right? So that's why I had you highlight. So if I look at my x values on my x-axis here, from what number to what number is this first section increasing? From what number to what number? From what number to? Perfect. And then what about this other increasing section? From what number to what number are we increasing? 3 to 7. Okay, so we're going to write those out. Okay. So when I write this out, We said -8 to 5, so we have to write this as parentheses -8, comma, to -5. That is how we write it. And then like Ariely said, the second one is from 3 to 7, so when we write that out, parentheses 3 to 7. Okay? So decreasing is where on the x-axis the graph is going down. So again, this is section 1 and section 5. We already know are increasing, so they're out. So all we have left is section 2, 3, 4, and 6. So tell me, what sections are decreasing, that are going down, like my hand here? Section 2. What's another section? Section 4. Very good. And we have one more that's going to be going down. Section 6. Okay. So these 3 are going down. Okay. Because if you show your hand, if you look at my hand here, it is going down like my hand. It is decreasing. So now we need to look at, again, the x-axis of where it's going down. So this first one, this first set, from what number to what number is it decreasing? This first one here, from what number to what number is it decreasing? Correct. So when I write that out, it's going to be -5, comma, to -2. That's how we write it in math. What about this second little bit? From what number to what number on my x-axis is it decreasing? Perfect. From 2 to 3. Oops. 2 to 3. And then we have one more. But this one's a little bit more difficult. From what section to what section, what x value number to what x value number is it decreasing? So it starts at 7, but then it has this arrow that's kind of going to the right forever. Oh, Ariely's got it. It's from 7 to infinity. Now the reason, even though my table here, my graph here stops at 10, because of this arrow, it means it is going to the right, even though it's going down as well, it is going to the right forever. And forever in math is that infinity sign. So when I write this out, it's going to be decreasing from 7 to, and I'm going to type in my infinity symbol here, to infinity. Infinity. Okay. 7 to infinity. Okay. Now we're going to talk about a constant. This is where the graph is flat. We only have one section that is flat, and I'm just going to highlight it because, well, it's the only piece that's left. How do you get the sign? Which sign? Okay, so our only flat section is the only section that's left, and that's this guy. So when I look, again, it's about our x-axis, right? When I look at this, from what number on my x-axis to what number is my graph flat? -2 to 2. Perfect. So when we write that out, -2 to 2. Beautiful. Amazing. Okay, so that's how we do increase, decrease, constant. Okay. Now we're going to talk about domain. Okay, now domain is all the x values on the graph. And we read that from left to right. So what I'm going to have you do is we're going to take, what color is this? Orange. Let's see if I can find an orange color. We're going to look at our graph. We're going to look at the leftist most part. What is the leftist most part of our graph? Do we see where that's happening at? What is our leftist most part of our graph, and what is its x value? Perfect. So this is the leftist part of our graph, and -8 is its x value. So let's start writing this out. So -8 is my leftist part, and it's an open dot. Does anybody know what an open dot? Are we going to have a parentheses or a square bracket? It will be a parentheses. The only time you'll see a square bracket is if it's a filled in dot. Okay, that's okay. Practice makes perfect. Now, we have to find the rightmost side of our graph. Okay, but what happens when I look at the right part of my graph? What do I see happening right here? It goes on forever. And what's forever in math? Infinity. So when I finish writing out my domain, because that right side has an arrow that goes forever, okay, it's going to be the infinity symbol. If this lets me write the infinity symbol. And the infinity symbol always uses a parentheses. Always, always, always. No ifs, no ands, no buts. Now we're going to talk about the range. The range, and I'm going to use purple for right now, the range here. So the range, it says, are all the y values of our graph, all the y values. So we're looking at our y-axis here now, all the y values. And we have to start from the bottom to the top. So what do we see happening at the bottommost part of our graph? What is that thing? It's an infinity, but it's going down. So is that a positive type of infinity or is that a negative type of infinity? That'll be a negative infinity. Negative infinity. Very good. So starting at the bottom. And then we have to go to the tippity-toppest part of our graph. So right here is my tippity-toppest. What's that? Y value for the tippity-top. 8. So it goes from negative infinity to 8. So all the negative y values, because that graph is going down forever. But the toppest, the tippity-topmost part of my y value, the biggest y value I can get is 8. Okay? Domain and range is super evil. So do we have any questions? Right here. So now let's talk about maximums. So maximums are high points where the graph changes from increasing to decreasing. So we write these as ordered pairs. Remember, x comma y. So somebody tell me, somebody tell me, where do we see a maximum happening? Where do we see a peak of where it changes from going to increasing to where it goes down to decreasing? Where do we see that happening? Okay, so we should see it happening right here. What is that ordered pair of that point? What's its x value? What's its y value? Beautiful. So we have negative 5 comma 6. Hey, that's supposed to be a 5. And then we have another maximum happening, right? Where we go from increasing and then it switches to decreasing. And that's right here. What is that ordered pair? What is that x value and its y value? Not 8 comma negative infinity. So this goes from a decrease to an increase. That is why it is our minimum. This guy here has an open dot. He don't count. We only cared about closed dots. This one over here, we do not care about because it's an arrow. It goes on forever. We only care about closed dots. So now we need to talk about x-intercepts and y-intercepts. Now, x-intercepts are where our graph passes through the x-axis. This line here is the x-axis. So we're looking at every place that our graph passes through. Let's use black. Let's use black dots. So going through my x-axis, my graph passes through right here, passes through right here, passes through right here, and passes through right here. Now, when we write x-intercepts, we write them as a number, comma 0. So looking at this first one here, what number is it passing through at? -7, and we write that as -7, comma 0. That's the first point. What about this next guy? How would we write this next guy? Beautiful, -3, comma 0. What about this next black dot? 5, comma 0. And we have one more. How would we write that last one? 8, comma 0. Okay, so that's all of our x-intercepts. So now we have to talk about our y-intercepts. So where a graph passes through the y-axis. And that is written as 0, comma a number. So it's flipped. It's flipped. So we're going to figure this out. We're going to find this in gray. So I go down my y-axis here. And it passes through at this point right here in gray. What is that number it's passing through at? Beautiful. It is passing through at 0, comma, -3. You do not have to do this slide. Okay? You do not have to do this slide. But, if you do this slide, I will give you extra credit. And I will give you extra credit for each correct box answer. Does everybody understand the flow I'm putting down right here? So if you choose to do this last slide on your own, I will give you a point of extra credit for each box that is correct. Okay?